So, Engineering Mathematics 1 syllabus contents. These are the modules. Module number 1 is matrices. Second module is numerical solution of transcendental equation and system of linear equations and expansion of functions. Third module will be complex numbers. Then fourth module will be hyperbolic functions and logarithm of hyperbolic functions and logarithm of complex numbers. Complex numbers. Fifth module will be partial differentiation. And the sixth module will be application of partial differentiation. Application of partial differentiation. And successive differentiation. So these are the 6 module differentiation. These are the 6 modules given in your syllabus. We have to go one by one. In this sequence, we are going to teach, or we are going to study these modules, right? So without delaying, we'll start with the first module. Module number 1, that is module 1, matrices. Now, what do you mean by matrix? This is the first question. You have already studied matrix in your early standard, right? What do you mean by matrices? याद है कुछ आपको? Matrix is an arrangement of numbers, right? In simple language, matrix is an arrangement of numbers, right? Before that, matrix was first coined by an English mathematician, James. Introduction. It was first coined by James Joseph Sylvester. Right? But the concept or the actual definition or term matrix was introduced by British mathematician Arthur Cayley. Right? Matrix means arrangement of numbers, right? As you can see, we can arrange the matrix in this 2 square brackets, right? Now, why do we study matrix? That is most important questions. Why to study matrix? Why to study matrix? This must be your main, what you can say, step for learning any new topic. Why to study this topic? Why is it given in first year, first semester, or why we are going to study this matrix? Now, matrix has a lot of what you can say applications or use in your day-to-day life as well as in your engineering field, right? For example, as you belong to ECS, we can say matrix used for extracting meaningful information from medical imaging devices such as MRI and ECG. MRI, ECG, right? Here the matrix is useful, right? Next, also you are belong to computer field, so matrix can be used in 3D models, then computer graphics, 3D modules, right? Also, as a mathematician, you must be knowing this cryptography or sending a secret message, right? In this also, matrix is useful. So, in cryptography also, it is used. Cryptography. Also, any other application you know? Matrix are also used to do search on Google. Search, I think you all know. Search on Google, right? For predictive test, for predictive test text by using Markov chain, page rank, right, etc., etc., page rank, etc. So these are very few uses of matrices I have given you. There are plenty of examples or plenty of uses of matrices in our day-to-day life. So without delaying, let us start with the definition of matrices. Yes, you have given in chat box image formation in computer for pixels, right? Then arrangement of numbers and rows, this is definition, right? That we are going to study now. What do you mean by matrix name? Definition, matrix. An arrangement of numbers, an arrangement of numbers in rows and columns is called matrix, right? For example, let us say A is a matrix given like this: 1 2 3 4 5 6. This is a matrix because it is arranged in numbers, rows and columns. These are called as rows, first row, second row, and these are the columns: first column, second column, third column. This will be its order. There are two rows, so two rows into three columns, so its order is 2 by 3, right? There are two rows, and this I can write down as rows, and this I can write down as columns, three columns, right? This is a rectangular matrix, right? In general, you can denote matrix as, in general, matrix A can be expressed as matrix symbol into ith row and jth column, meaning ij is the order of the matrix, or simply aij. This is the notation for matrix. In general, I denote number of rows and j denote number of columns, right? So this is the definition of matrix. Next concept is type of matrices. Now few type of matrices you already knows. Type of matrices. Type of matrices, right? First is square matrix. Now what do you mean by square matrix? Square matrix, ये थोड़ा शॉर्टकट में बताएंगे बिकॉज हमारा जो मेन कंसेप्ट है वो सिमेट्रिक्स क्यों सिमेट्रिक्स से स्टार्ट होगा. ये स्क्वायर मैट्रिक्स वगैरह आपने आपके पहले अर्लियर स्टैंडर्ड में सीखा है, राइट? सो a matrix having equal number of rows and columns is called square matrix. A matrix having equal number of rows and columns and equal number of columns is called square matrix. Square matrix, right? For example, let us say A is a matrix, say 1 2 3 4. As you can see, there are 2 rows and 2 columns, so this is a square matrix of order 2. ठीक है? Next is diagonal matrix. Diagonal matrix. Diagonal matrix. What do you mean by diagonal matrix? A matrix whose non-diagonal elements are 0 and diagonal elements are either 0 or non-zero, right? A matrix whose non-diagonal elements is square matrix. A square matrix. Let me erase this. A square matrix. Diagonal matrix must be a square matrix. Square matrix in which all non-diagonal elements are 0. Non-diagonal elements are 0. And diagonal elements are either non-zero or 0 or 0, right? For example, let me take an example of say 1 0 0 0 0 0 2 0 0 0 0 say 0 3 0 0 0 0 0 0 0 and the last one 0 0 0 0 and 4. This is a matrix of order say 5 by 5, and as you can notice, this is your diagonal पोजीशन एलिमेंट, राइट। यहाँ पे डायगोनल में आपके नॉन जीरो या जीरो है, लेकिन नॉन डायगोनल एलिमेंट्स, ये एलिमेंट और ये एलिमेंट सब जीरो है। दिस इज कॉल्ड एज अ डायगोनल मैट्रिक्स। इज इट क्लियर? नेक्स्ट concept is third one, scalar matrix. What do you mean by scalar matrix? अब थोड़ा शॉर्टकट बताऊंगा। It is a diagonal matrix in which all diagonal elements are equal. All diagonal elements are equal. Say, for example, A is a matrix, say 5 0 0 0 5 0 0 0 5. As you can notice, the diagonal elements are equal, that is nothing but 5, right? Next concept is, ये हो चुका है एक्चुअली, इसलिए हम लोग थोड़ा सा आगे बढ़ेंगे। थर्ड वन और फोर्थ वन, unit matrix. What do you mean by unit matrix? It is a scalar matrix with diagonal element as unity. It is a scalar matrix with diagonal element equal to as unity, right? For example, say I is equal to 1 0 0 0 1 0 0 0 1. Unit matrix you already know, right? This is unit matrix of order 3. You can also write down unit matrix of order 2, 1 0 0 1, right? Next concept is fifth one, upper triangular matrix. Now upper triangular matrix, lower triangular matrix, you can understand. Upper triangular matrix, a square matrix, in which all the elements below the diagonal principal diagonal are 0. Below the principal diagonal are 0. Diagonal are 0, right? For example, E is equal to 1 2 3 0 4 5 0 0 6. Now as you can notice, this is your principal diagonal. And below this principal diagonal, all the elements are 0. So this is called as upper triangular. The case is reverse. जब below में आपके 0 रहेंगे, you can call it as upper triangular matrix. Whereas if sixth one, lower triangular matrix, क्या होगा? A square matrix in which all elements above the principal diagonal are 0. 0. Then, for example, let us say A equal to 1, 2, 3, 1, 0, 0, 0, 4, 5, 6. This is a lower triangular matrix where this is your principal diagonal, and above the principal diagonal all elements are 0. Is it clear to everyone? Next is next type of matrix is column matrix and row matrix. I think this is very easy. A matrix having only one column, column matrix. Column matrix. A matrix having a single column. Matrix having only a single column. Matrix having a single column. Single column. एक मिनट हाँ. So a matrix having a single column is called as a column matrix. For example, say A is a column matrix. Say 1, 2, 3. It's a column matrix. Next is row matrix. A matrix having a single row. A single row is called as row matrix. Say for example, A is equal to 4, 5, 6. This is called as a row matrix, right? Very basic thing. इतना डिटेल में बताने की जरूरत नहीं है. एक्चुअली ये आप लोग पहले ही पढ़ चुके हैं, बट क्योंकि हमारा पहला लेक्चर है तो थोड़ा इंट्रोडक्शन हम लोग बेसिक से कर रहे हैं. नेक्स्ट इज ट्रांसपोज ऑफ मैट्रिक्स. नाउ ये तो आपको पता ही है, ट्रांसपोज of a matrix. What do you mean by transpose of a matrix? Interchanging the rows and columns. The matrix obtained by interchanging rows and columns. Or columns and rows, right? For example, if A is a matrix of order say 3, say 1, 3, 5, 4, -1, -2, 3, 6, 0, 1. This is the matrix. Then its transpose is denoted by A transpose. You can write down A dash or A transpose T. It is nothing but interchange rows and columns. First row is 1, 3, 5. I will write it as first column. Then second row is 4, -2, 3. I will write it as second column. And then 6, 0, 1. This is called as transpose of a matrix, right? Next is symmetric matrix. Now यहाँ से हमारा main topic start हो रहा है. Next matrix is matrix number 10, symmetric matrix. Symmetric matrix. If a square matrix A, if for a square matrix A, A transpose is equal to A. If you interchange rows and column, and if you get the original matrix, then you can say that A is a symmetric matrix. Then A is symmetric matrix. right? If you interchange rows and column, and if the matrix is the same matrix, original matrix, then you can say that A is a symmetric matrix. Let us say, for example, A is 1 3 5 3 4 1 and 5 1 9. Now if I find its transpose, let us say its transpose is interchanging rows and columns 1 3 5, then second row has 3 4 1, I will write it as column, and then 5 1 9 as a column. If you observe, A and A transpose are same. Here A transpose is nothing but A. This implies that A is symmetric. Okay, A is symmetric. Now what do you mean by next part is 11, skew symmetric matrix? What do you mean by skew symmetric matrix? Skew symmetric matrix. Skew symmetric matrix. If for a square matrix, if for a skew symmetric matrix, if for a, let me erase this, if for a square matrix, A transpose is nothing but negative of A, that is minus A, then A is a skew symmetric matrix. Then A is skew symmetric matrix. A is skew symmetric matrix. Let us say, if you interchange rows and columns, and if you get the original matrix but the sign are changed, plus minus ho gaya, minus plus ho gaya, then you can say that your matrix is nothing but skew symmetric matrix, right? For example, say A is equal to 0 5 7 minus 5 0 3 and minus 7 minus 3 and 0. If I find its A transpose, then interchange rows and columns 0 5 7, first row as a first column, second row as a second column, and third row as third column. So if you observe, A transpose 0 5 7 0 minus 5 7 minus 5 0 3 5 0 minus 3 minus 7 minus 3 minus 0 7 3 0. If you notice, it is nothing but the original matrix, just the sign are changed, and therefore A is skew symmetric matrix. A is skew symmetric matrix. Okay, is it understood? Next is determinant of a matrix. What do you mean by determinant of a matrix? Determinant of a matrix. Let A be a square matrix. A be a square matrix. Then determinant of A is denoted by determinant of A if first condition is that determinant of A is not equal to 0, then the matrix, if determinant is not equal to 0, then the matrix is called note that let A be a square matrix, then determinant of A is denoted by determinant by this symbol, right? Next, there are two conditions or there are two concepts. First is if determinant of A, let me first of all show you how to find the determinant. Let me erase this part. I will first of all see how to find the determinant. You already know, but let me revise this. Determinant of A is, let us say for example, 2 by 2 का देखते हैं, simple सा देखते हैं, 1 2 3 4, simple सा. Then its determinant is denoted by this symbol. It is nothing but two vertical line, 1 2 3 4. It is given by multiplying this into this minus this into this.